Welcome to qnawire.
We have the situation in which we're going to have a bead that is going to slide a curved wire. We don't know what is the shape of the wire, but we know that the height at two different points from A and B are going to be respectively h1 equal to 5.89. Let me redraw that because that looked horrible. H1 equal to 5.89 meters and H2 equal to 1.76 meters. Over here, what we want to know is what is going to be the speed, the magnitude of the velocity at B. So in order to solve this, we know that the initial velocity is equal to 0 and that we're going to obey conservation of energy. So the change of energy needs to be equal to 0. Thus, the change of kinetic energy plus the change of potential energy needs to be equal to 0. The change of kinetic energy is going to be 1/2 of mass times final velocity squared minus initial velocity squared, and the change of potential energy is going to be equal to mass gravity times h2 minus h1. And all of this needs to be equal to 0. Remember that we can apply conservation of energy because of the fact that we're on a frictionless surface. So the initial velocity in this case is going to be equal to 0. Thus, the value for the final velocity would be 1/2 of mass times final velocity squared would be equal to mg times h1 minus h2. Mass and mass cancel out, and we're going to get that the final velocity is going to be equal to 2 times gravity multiplied by h1 minus h2, and taking the square root of all of this result. Thus, the final velocity, taking the value for gravity as 9.81 meters per second squared, is going to be 5.89 minus 1.76 meters. Notice that the units inside are going to be meters squared divided by seconds squared, which upon taking the square root gives us meters per second. So the result is 9.00 meters per second. And with that, it would be all. Thank you very much and have a good one.